Land Shop, Part 3, Off Topic, Land Navigation. So, in this section, we're going to discuss well, first off, we're going to discuss locating your pretty much exact position on a map. And then secondly, we're going to discuss the UTM grid system and using it to navigate, to find locations on a map, draw your azimuth on the map, and translate it to your compass, add or subtract your magnetic declination, and then whoop, set your line of travel and off you go. So, let's talk about, before we go actually to the map, let's talk about the UTM grid system. Universal Transmercator Grid System. I have no idea where that term came from. I just know that's what it's called. It's real simple. That's it. So I can't tell you any more about that. There's also a military grid reference system, MGRS, and there's another one that I really don't remember off the top of my head. But we're going to talk about using the UTM grid system for the purposes of this video. So let me reposition the camera once again so we can look at the map and we'll get to work. Here you see the numbers across the bottom of the map. This one is 416. This one is 417. Notice the 4 is very small, the 17 is large, same with this. All these numbers relate to are the kilometers that this grid line is from the central meridian of this zone that this map is drawn for. That's it. Kilometers from the central meridian that this map is drawn for, and that's kilometers going east. This number right here is 45, a small 45 and then a big 12. So what these numbers represent are 4,512 kilometers north of the equator. So that's what this grid line is here, 4,512 kilometers north of the equator. Okay, now when you deal with UTM grid systems, you're given two sets of numbers. They are called easting and northing. You might as well just drop the ings and think east and north. So your first coordinate is going to be going along this bottom line right here that measures west to east. Your second set of coordinates is going to be here, measured across this line, going south to north. That's it. Real simple. So if I were to say to you, grid square or coordinate 23 by 19, you would first off scan across, and I'm going to try and pan the camera. You would pan over to right here where it says 23, which is this line right here. Let's move the camera a little more. There we go. 23. And then look for 19. So I need to move some stuff around on the table here. I'm just gonna flip the map over. Whoop, wrong way again. There we go. I'm gonna flip the map over. So here's 23 and here's 19. And again, we connect those two lines, 23 and 19, this grid square right here. Again, this is a 1 kilometer grid square. So those two numbers will give you down to 1 kilometer. If I were to say 238 by 195, 23, 19, you would get your little 100-meter subdivision, go to 2319, lay that on there, line that grid up with the meridian lines on the map. Now let me see if I can focus in on that. There might be too much of a reflection, I hope not. There we go. Yeah, it's fairly visible. So, remember I said 238 by 195. 238, well, 23 and then 8 by 195, 19, 5, come over to the 8, somewhere in this 100 meter grid right here is the coordinate we're looking for. Actually, that 100 meter grid is the coordinate. But if I were to add another place, go out to 4 numbers, or what's referred to as an 8-digit coordinate, it would be 2388 by 1950. So I would have to get this little grid tool right here. This will locate me down to a 10 meter square plot. And the way this protractor works, the way this map tool works is you line up your grid square, 23 by 19, and then you line this bottom meridian here up with this 1 in 24,000 scale right here. Just like that. Then you use your easting coordinate. The last two is 88. 88 is right here. You slide this over until the left-hand meridian line, or 23, is on 88. And then you make sure your bottom meridian's all lined up. And then you would find the second coordinate, 50. So we've got 19, 50. That puts it right there, right in the middle of that line. And lo and behold, it's the intersection of 2nd Street and East Moser Avenue, right there. Not terribly complicated, but it does take some understanding. And it does take someone to show you. So, if I said the second grid coordinate was at 2488, 1990, well, we have to locate grid square 24. So we know this one's 23. 24. We know, like I said, we know this grid right here is 23. 24 is right here. And then 24, 1990. So we're on the same northing grid, but our eastern grid has moved 1 to 24. Or our east grid has moved 1 to 24. If I said 248 by 199, we can take our 100 meter tool and lay that on there. Line this outer square up with the 1K grid. 248, 199. So we're going to be in this 100 meter grid square right here. To take it down to the 4th digit, we need this tool again. Once again, you line it up, line the bottom up with the grid square, line this meridian right here up with this slot, slide this to the left until we get to 88. So we slide that to the left. That looks to be about 88 right there. Make sure we're parallel with the 19 grid line. and then we go up the scale and find 90. Here's 90, we put a dot, and lo and behold, we're right here at the end of Spring Street again. Not terribly complicated, but just as before, we did the same thing. Now, if you need to find your path, you simply lay a straight edge, draw your line, put the protractor on the start, line it up with the meridians on the map, get your bearing. Again, it's going to be the same thing, 0.67. Add your magnetic declination of 12 degrees, or not 0.67, excuse me, 0.67. Add your magnetic declination of 12 degrees. You have 0.79. You set your compass just like we did in the last series, in the last video, and there's your line of travel, and off you go. Now let's talk about finding yourself on the map. So let's say you find yourself next to a lake. And this is the easiest way to do it on this map. It might be a hilltop that could require you to really pay attention to the lines here on the map. But let's say you're on the shore of a lake. You can see the end of the lake here, and you can see the breast of the dam here. Well, you're looking out over the lake, so you're obviously looking south to north. I'm sorry, north to south. What you would do at this point is shoot a bearing. Let's say you're standing here. You don't know you're standing there, but we're just going to use that for an example. Take your compass, shoot a bearing to a visible landmark. Put that landmark on the map. You say you're shooting 270. Well, it's not going to be 270, but what you would do is then you would draw a line, set your protractor on there, and you would have to determine, if you're working from north to south, you would have to determine your back azimuth, which is the opposite of the bearing you're looking at. So, if you're looking at 090, your back azimuth is going to be 270. So you set your map tool on there. Because the map is oriented south to north, and you're looking the opposite direction. Find your back azimuth, mark it somewhere on that protractor, and then draw your line. Then you would shoot the bearing to another location, just like this, and draw your line. Where those two lines intersect, that is almost your exact location on that map. Now from there, so you know you're here, if someone says go to grid square 2381950, you can get a straight edge 2319 right here. Find your exact grid location right here. Get a straight edge. I don't have one long enough. Yeah, I do. Right here. There we go. Find a straight edge from your present location to where you need to go. Draw your line. Set your protractor, align it with the mat, 110 degrees plus 12, 122. Get your compass. Align it with the mat. Set your declination to 122 degrees. Line your compass up, and there's your line of travel, and you're off and running. Granted, with this course, you're going to have to do some swimming, but that's pretty much it. If you needed to navigate around an object, you would measure the distance, inch on a centimeter scale, from, say, right here. You could measure the distance, walk over here, do the math, walk down here, this way, do the math, and back to your line of travel, and then reshoot your bearing. But anytime you're navigating around an object, it's easier to go in 90 degrees. So you would turn 90 degrees from where you're at, from where your compass is set from your line of travel here, 90 degrees this way, or rather straight this way, then 90 degrees down and re-intersect your line of travel here. Reset your compass, get back on your line of march or line of travel, and go right to where you need to go. Now, in the example navigating around the lake, if you're on the shore of the lake, it would be a very simple measure to shoot a bearing to the opposite end of the breast of the dam. Something you can see. In that case, you can just walk along the shore, cross the breast of the dam, and you're at that landmark. And then get back on your original line of travel. But if you were navigating around something like a boat inlet at a lake, you would walk 90, 90, and then another 90 and find your original line of travel. Or you could shoot a bearing to a landmark on the other side of the lake and then just walk around it to that landmark and go. If you can see the landmark of something you need to navigate around, you're pretty well set. So that's pretty much it for the three-part off-topic land navigation. I hope it helped. I hope I gave you some good information. If you have any comments or questions, as always, I encourage you, leave them below in the comments or questions section. On the first video, I posted a link to Analytical Survival's YouTube channel, where he does an excellent three-part series on land navigation. Goes over everything I did, but in pretty much greater detail, especially the UTM coordinate system. I used it for the simple purposes of exposing you to the information and, you know, showing you how it actually works. But Analytical Survival did a really good job with his three-part series. Even though he says it's five-part, it's a three-part series. So, as always, thank you for watching Basement Gun Shop. If you like the channel, like it, subscribe, even better. And until next time, stay safe and keep shooting.